Learning goal number 24, angles and polygons. All right, learning goal number 24, polygons and angles. Here we go. A polygon is a closed figure made up of straight lines. So for example, three-sided polygon would be called a triangle, which we have seen before. A four-sided polygons can sometimes be referred to as a square, a rectangle, a trapezoid, but quite frankly, we just call them quadrilaterals. So a four-sided object is called a quadrilateral. Five-sided is a pentagon. Six sides would represent a hexagon. Seven is a heptagon. So you can start seeing that the word gon is reused over and over again, and these first parts are coming from their prefixes to represent the numbers we're looking for. 8 is octagon. 9 is nonagon. And finally, 10 is a decagon. So those show up more and more as we go further into geometry. Again, 3 triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, and 10 decagon. Now, not only are we talking about polygons, we're talking about their angles. And primarily, we're referring to their interior angles. An interior angle is an angle that lies inside of a polygon. Right there. This angle. That's considered an interior angle. But primarily, we're going to be talking about the sum of those interior angles and adding them all up. So, for example, let's talk about the sum of interior angles represented here. First of all, a triangle has 3 sides, right? 3 sides, and it adds up to 180 degrees inside. A triangle has 180 degrees. So to fully understand this, we need to first start with understanding that. Now, if you take a look at a quadrilateral, a 4-sided object, and you actually separate it into triangles, like if I start here, and if I were to draw a line to every other corner, well, that one's already there, that one's already there. But if I draw this one, you actually see 2 triangles. And a triangle has 180 degrees inside of it. If we add up all the angles, that's what I mean by sum, adding up all the interior angles. So there are 2 triangles here. If I take 2 times 180, I actually get 360. Well, inside of any 4-sided object, all of the interior angles will add up to 360 degrees. 3-sided objects, triangles, add up to 180. 4-sided to 360. So let's take that same understanding and look at a pentagon. If I start at this corner and I draw a triangle to every other corner, that one's already drawn, so is that one. But if I go here and here, you can see that I now have 1, 2, 3 triangles. So if I take 3 times 180, I actually get 540 degrees. So there are 540 degrees in every 5-sided object or in every pentagon. So what we need to understand here is when there was 3 sides, we multiplied 180 by 1. There are 4 sides, we multiplied it by 2. There are 5 sides, we multiplied it by 3. If there were 6 sides, a hexagon, there would be 4 triangles inside. Basically, to find the sum of the interior angles of any polygon, we're going to take the number of sides, n, minus 2 from that. That will represent the number of triangles that are inside of it. Then we're going to multiply that by 180 degrees, which we just did here. You just didn't realize that at first. So 4 minus 2 is 2 times 180. 5 minus 2 is 3 times 180. And this is the formula we're going to use to find the sum of the interior angles of any polygon. Okay, so let's jump right into an example here. We want to find the sum of the angle measures of a decagon. Okay, every time I use a formula, I always write it. Let me say that again. Every time I use a formula, I write it. Why? Because if I write a formula 100 times and use it 100 times, I'm going to remember. But if I look at it 100 times while I use it, might not remember it. So always write the formula you're using to commit it to memory. N minus 2, n refers to the number of sides, times 180. So I want to find the angle measure for a decagon. A decagon has 10 sides. So I'm going to take 10 minus 2, multiply that by 180. 10 minus 2 is 8. 8 times 180, 8 times 100 is 800. 8 times 80 is 640. So you got 1,440 degrees. In a 10-sided object, a decagon, all of the angles, every single angle, if you add them all up, you get 1,440. All right, so before we finish off here, we got a few vocabulary words that are very important. Equilateral. If a polygon is said to be equilateral, that means all the sides are congruent. Equiangular. If a polygon is said to be equiangular, all of the angles are congruent. And then if you have a regular polygon, that means it's both equilateral and equiangular. For example, we are all familiar with a square, okay? So a square is equilateral, meaning all the sides are congruent. So we would use those dashes to represent that. Those dashes represent congruency. That means this side's congruent to that side, and that side, and that side. And then also, all the angles of a square are 90 degrees. So we use these little arcs to represent that. It means it's equiangular. That's how we represent angles are congruent. So pay attention to how we represent sides are congruent and how we represent angles are congruent. Now, what we need to understand is that that's equilateral and equiangular. So a square is actually a regular polygon. Okay, so moving down to our example number 2. What is the measure of one interior angle? We're only finding one angle of a regular decagon. Okay, so here's the understanding we need to figure out. We need to first realize that a decagon is 10-sided, and the sum of all of the angles of a decagon is 1,440 degrees. How do I know that? We just did that problem previously. So if the sum of all of them is that, and it's regular, that means they're all going to be the same. So you have 10 angles to go with 10 sides, and they're all going to have the same measure. So if I want to find the measure of one of them, I'll take this and divide by how many there are. Or I'm going to take 1,440, and I'm going to divide it by 10. Because there's that many degrees in the whole decagon, and there's 10 congruent angles. So divide by 10. And one angle in a regular decagon is 144 degrees. Okay, so there was a lot of vocabulary there. There was some formulas, but I want you to give these two problems a try on your own.